Okay, guys, we're back to it in the Unit 6, the Probability and Data Analysis unit. So we're going over the Day 2 notes on page 18. Today we're going to discuss another visual for data, looking at data and numbers. It's called a Box and Whisker Plot. They are a great way of organizing a large amount of data and seeing how things are spread out. So when we're creating a box and whisker plot, the data is actually broken into 4 equal sections. As you can see right down here, we have 4 equal sections. We have the 2 boxes and the 2 whiskers. So how the 4 sections are split up is, imagine if you had like 1,000 numbers that you had written out and you wanted to see how they were spread. So, if you had 1,000 numbers, that means the 250 of them would be right here. Another 250 of the numbers would be jammed in here. Another 250 of them would be here, and another 250 of them would be here. And of course, when I say where the numbers are, usually this number line would have numbers on it, but it's just showing a real abstract view of it. So keep in mind for today that we're talking about how numbers can be spread out over a number line. So when creating a box and whisker, again, it's broken into 4 equal sections, 25% each of each chunk. You cut the data. To do it, we cut the data in half by finding the median. Of course, if we're given a bunch of numbers, we're going to have to put them in numerical order to find the median, which is the middle number. And then we find the median or the middle number of the first half, and that's called the first quartile. And then we'll find the median of this, or middle number of the second half, which we call the third quartile, as you can see below here. And then each, as I said a minute ago, each section represents 25% of the data. So here's parts of a box and whisker plot. You can see in the diagram the middle number, or let me start with minimum number. That would be the lowest number would be here. The first quartile is the middle of the, if you took the first half of the numbers or the bottom half of the numbers, the first quartile would be the middle of those, and that would be the left side of the box, as I just highlighted. The lower quartile is also known as the first quartile. The median is the middle number, also known as the second quartile. So that would be right here, the median would be. It's the middle of it splits the boxes. The third quartile is also known as the upper quartile. That would be here. That is the, if I took it's the middle of the highest half of the numbers, sorry. And then, of course, the maximum number is where the right whisker is. That would be the highest number of all of your numbers. So it's pretty simple. It seems pretty confusing at first, but trust me, it's much easier than it looks. Again, this is just visual data. If you had a ton of numbers and you wanted to see how they were spread out, you would put them with this visual with a number line. And again, of course, the number line would have real numbers in it. This one just does not. And then there is also this last thing called Inter-Quartile Range. And what it is to see where the middle 50%, that middle 50% chunk of numbers, how spread out it is. And when we see how things are spread out, we call that the range. So the Inter-Quartile Range, which is IQR for short, that would be if you took the third quartile and minus the first quartile, whatever those numbers would be. So you'll see more of that on the next page. Okay, so right now we're going to create a box and whisker plot for the sets of data. So the first thing I'm going to do is put these numbers in order. That is very important to put the numbers in order. So it would be 9, 12, and so on. All right, so those numbers are now in order. So what we do is we go make a number line. And we go, okay, it's 9 to 38, so let's go 0, 5, 10, 15, 20, 25, 30, and 35, 40. Make a good, nice, consistent number line. I like number lines that have numbers that are in like 5s and 10s and so on. All right, so then what I usually do is I go to look where the middle is, the median. So it would be actually right here in between 22 and 24. So add them up and divide by 2, and of course that would be 23. So again, that's the median. So that'll be a middle line right here. We don't put it on the number line, we put it above the number line. And then with the first quartile, so I look at my first half of the numbers, which is the middle number here. That would be right here. That is my first quartile. So that's my left side of my box where 17 is. Connect it. And then for my third quartile, I look at my top half of numbers. My middle number there would be 29. So that's called my third quartile or upper quartile. So 29 would be the right side of the box, and then I connect it. So there's my middle chunk, my middle 50% of my numbers. And then for the whiskers, you just go draw some whiskers down to the lowest number, 9, and then up to the highest number, 38. And that's it. That's how you create a box and whisker plot. It's very easy. Okay, letter B. These are not in order. All right, so I got to put them in numerical order. 10, 10, 11, 12, 12, 12, 13, 14, 15, 17, 18. So then my middle number of those would be just counting inward. My middle number would be right here. That's my median. So then I do need to go do my number line. So it goes from 10 to 18. So I'll go 10 to 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, 19. Not the prettiest number line, but you get it. All right, so the median, the middle of the box right here at 12. All right, so for the first quartile, I look at the first half of the numbers. So I'm looking at these. What's the middle number there? It would be this 11. So first quartile, left side of my box. And then your top half, the middle number there is at 15. So that's the third quartile. So that's the right side of the box. And then the whiskers go down to the lowest number, 10, and the highest number, 18. And that's it. Okay, so next we're going to create a box and whisker plot, and then we're going to answer the follow-up questions for the data. Nice thing is these are in order. So let's go with, let's go in 10 since it goes from 20 to 52. So 20, 30, 40, 50, and 60. and then we'll just put marks for the 5s in between. So the 1, 2, 3, 4, 5. There is no middle number here. There's 8 numbers. So the median will be, I'm going to have to do add them up, divide by 2. So that'll be 71 divided by 2 is 35.5 is my median. So that's my middle of my box. So that would be right around here. And then what's the middle of your first half? That would be, again, that would be here. So your first quartile, you're going to have to add up, divide by 2. That would be 26.5. So that would go right about here to the left side of my box. And then the upper half, my middle number, is between 48 and 50. So that's my third quartile. Add them up and divide by 2. And that'll be 49. So that'll be my right side of my box. Really spread out middle. The middle numbers are really spread out, those middle half or middle 50% of my numbers. And then the whiskers go down to your lowest number, 20, and up to your highest number, 52. All right, so let's do some questions for this. So again, we need to remember the data is broken up into 4 parts. Therefore, each section represents 25% of the numbers of the data. So number 1, what percentage of the data is above the median? Well, the median is always the middle, so what percent is, that would be 25 and 25, 50% of the data is above the median, half below, half above. What percent of the data is below 49? So 49 is at the third quartile. Percent, there's 3 sections to the left, 1, 2, 3. So that would be 25, 25, 25 would make 75. So 75% of the data is below 49. Number 3, what percent of the data is between the first and third quartile? Well, that would be the middle half. The box always represents 25, or the whole box is 50% of the data. Each little box is 25. So number 4, what percent of the data is above 49? So that would just be this whisker, and that's 25% of the data. And what is the interquartile range? We have to subtract the third quartile minus the first quartile. So what we're going to have to do is 49 minus 26.5, and that'll give our answer there. It is 22.5. So again, for that calculation, what did I do? You had to take quartile 3 minus quartile 1. All right, so let's do some more questions. So here's a box and whisker plot. Colby graphed some data shown in this box and whisker plot. We don't know how many numbers there are. We just see how they are spread out. So we got a multiple choice question. Which statement is true about Colby's data? So the range of the data is 25. Well, that didn't say interquartile range. That just said range. So range is highest to lowest. That would be, what number is that? That would be 95. And then minus that's 25. 95 minus 25 is 70. So no, the range is not 25. So A, no good. B, 1/2 of the data are below 65. If I highlight that 65, that would be below 65. That's just a whisker. That's 25% of the data, not one half. One half it would have to be 50%. So B's no good. Letter C, the median of the data is 60. No, absolutely not. 60 is right here. No. The median of this data is always here, the middle of the box. The median is actually 75. So C is garbage. And D, 3/4 of the data are below 90. That would be true. 90 is right here, and we have 3 parts below it. We got a box, a whisker, so 3/4. Three parts out of the 4. So letter D. Example 4, Mr. Cooley's health class recorded the number of push-ups each student could do in 1 minute. The results are shown in the box and whisker plots below. You can see males on the top and females in the bottom if we were to put that data down. So, which of the following statements are true? So it says here for the first one, the interquartile range, the interquartile range for males is equal to the interquartile range for females. So let's check those out. So for males, that would be 23 minus 17 would be 6 for males. Let's do the females in red. Their interquartile range is 20 minus 8, or 20 minus 12 is 8. So that is not equal. So, yeah, the IQR for the males is definitely not equal to the IQR for females. All right, what about the median? The median number, let me go erase a little bit up here. The median number of push-ups for the males is greater than the median number of push-ups for females. Well, the median for males is right here. That's 20. The median for females is 15. So that is true. The median number is higher for males. Actually, we're going to check out more statements. This is actually not just a single multiple choice. You can actually, this is one of those things where you have to check all boxes that are true. So we do have to test all of these out. So the third one, all of the males did more push-ups in 1 minute than 25% of the females. So that would be a true statement. All of the males were 12 and above, and then 25% of the females were right here. So you can see all of the males did more than 25% of the females, because that first 25% that I highlighted is just 10 through 12. So that would be a true statement. The fourth one, the data for the males has a larger spread than the data for the females. That's a little bit of a confusing statement. When it says spread, spread actually means range. Range and spread. Its range is how things are spread out. So it says here the data has a larger spread than the data for the females. So I need to check range here. So the range for the, let me do males in blue again. The highest number is 25. The lowest number for the males is 12. So that would give a range / spread of 13 for the males. The females, the highest is 24. The lowest is 10. That would give a spread / range of 14 for the females. So therefore, this statement would be wrong. So we're going to put a no. The data for the males does not have a larger spread for females. All right, so and then the fifth one, both 50% of the males and 50% of the females did between 12 and 20 push-ups in 1 minute. I'm going to highlight a little bit to show you again, so it's saying half between 12 and 20. So would that be true for the males? So if I'm looking at the males, 12 and 20, that covers a whisker and a box. So yeah, that would be 50%, 25 and 25 for each part. So that holds true for the males. And what about the females? They're 12 through 20. 12 through 20, yeah, that covers two boxes. 25 and 25 does make another 50%. They just were different between them, but they still covered 50%. So therefore, that would be, yes, that's a true statement. Okay, moving down, example 5, summer sales. So you can see in thousands of dollars going up the y-axis for 4 months here. And so a company made a bar graph showing the amount of sales for each month in thousands of dollars. Which of the following is closest to the range of sales for the 4-month period? All right, so we do have a multiple choice. So how would we do this? Well, it's actually easier than it sounds. It's just talking about range. So let's focus in on that word, range. So let's figure out the range of the sales. Remember, range is just highest to lowest. The highest is in June, and the lowest is in July. So let's calculate what that range is. The June has 8,000 minus July's 3,500, and that gives a range of $4,500. So there it is. D is your answer. Okay, guys, that's the end of my lesson. Hope you learned something new today. And you all have a great day.